Alright, welcome to the topic 11 review. This is some of the topics that we've gone over, and then I've got some problems that are actually pretty hard problems, so if you can do these problems, you're going to have a pretty good time on the test. Alright, so let's go through all these. First thing it says, know the difference between faces, edges, and vertices. That's just 3D shapes 101. So if I were to draw, say, like a cube looking thing, how many faces does it have? It's got these 3 faces, but then it's got one on the bottom, one on the side, and one on the back. So that'd be 6 total faces. Faces are like these flat parts. Edges are where the faces come together. So you could count up all of the edges, and there's more edges that are unseen, and then the vertices are all of the corners of the solid. Alright, identify solids and their nets. If I were to take this solid and make its net, it would look something like this. We'd have 4 lateral faces, and then you'd have a bottom face and a top face. And so if those were to be folded onto each other, it'd look like that. How does surface area and volume relate to each other? Here's the deal. They're not really related to each other. For example, if I take like a balloon or a ball and I make it bigger, I'm increasing the surface area. The surface area is getting bigger. What's happening to the volume? The volume is getting bigger. So increase surface area implies increase in volume. However, look at this picture. I took the cube, which has a certain volume to it, and I took out the cone. Now, did that increase or decrease the volume of the cube? Decrease the volume. I took space away from the cube. So decrease in volume. But what about surface area? Look at all this extra surface now that I've got. I've got the whole surface of this cone. I actually increased the surface area. So really, surface area and volume have nothing to do with each other. In this scenario, volume decreased, surface area increased. In this scenario, volume increased and surface area increased. So there's really no relationship with those. People have a hard time with that. What is the height versus the slant height of a pyramid? If I were to draw, let's say a cone. A cone is a pyramid with a circular base. The height is measured from the very top straight down at a right angle to the base, whereas the slant height is measured on the slant, and it's called L for slant height, and we use H for height. Lots of times you'll have to set up a right triangle and use Pythagorean theorem to figure out one of these lengths, or this would be the radius of that. So you got radius, height, and slant height, and you can use Pythagorean theorem to figure out one of those values. What is one measurement that is needed when working with a sphere? When you're working with a sphere or hemisphere, the only thing you need is a radius. That's the only measurement there is. The only measurement there is in a sphere. So basically every sphere problem at its heart is a find the radius problem. I could give you the circumference of this circle and you have to find the radius. I could give you the surface area and you have to find the radius. Every sphere problem is a radius problem. Find the volume and surface area of a composite. That'd be like this one. So we'll get to that one in a second. This is 2 cones put with a cylinder, we can find the volume and surface area of that. Find the surface area and volume of a hemisphere. Alright, you do have a formula for that in your formula packet. So let's get started. Question number 1. This is a trapezoidal prism. And one of the big questions that I have for you here is, what's the height of this prism? I know what you're thinking. You're thinking the height of this prism is 2.4, but that is not how we define height. Height is defined in this scenario as how far is this trapezoid from this back trapezoid. And that would be 3. 3 is the height of the prism. What's the height of the trapezoid? The height of the trapezoid is 2.4, but the height of the prism is 3. Alright, so now we can do let's do the surface area to begin with. The surface area of a prism is 2 bases. You got the front base and the back base in this scenario, and then there's a little shortcut plus HP. B is the area of the base, P is the perimeter of the base, H is the height of the prism. So I like to go like this, put my blanks, fill in my blanks if there's something obvious. So for example, the height is 3. Plug that in there. That's about it. That's obvious. Now we got to get working on the area of this trapezoid. Now the area of a trapezoid is the average of the bases of the trapezoid times the height of the trapezoid. This H is different from this H. This is the height of the prism. This is the height of the trapezoid. So let's figure out the area of this. So it'd be 1.6 plus 3.2 divided by 2 times the height of the trapezoid, which is base to base of the trapezoid, which is 2.4. Now I'm just going to plug that into my calculator real quick here. 1.6 plus 3.2 divided by 2. That's the average of the bases times the height, which is 5.76. Alright, so that is what we plug in for this. 5.76. Now we got to find the perimeter, which means we got to figure out this little slanted piece is right here. And that's going to take a little field trip as well. Now, if I do it like this and make a right triangle, if I make this 1.6 and make this 1.6, this is also has to be 1.6, because what's 1.6 plus 1.6? 3.2. Alright, so that's how that works. This is 2.4. I got to figure out what this length is right here. This is 2.4. So I got to use the Pythagorean theorem real quick to figure that out. So I'm going to use 2.4 squared plus 1.6 squared. And then I'm going to do the square root of that. 2.88 roughly. We'll call it 2.9. So therefore the perimeter of this shape would be 3.2 plus 2.4 plus 1.6 plus 2.9, 10.1. So the perimeter is 10.1, which is what you plug in right there. So now I've got everything I need to find the surface area of this solid. That's 2 bases plus height times the perimeter of the base. Alright, so plug all that into your calculator, and you're going to end up with 2 times 5.76 plus 3 times 10.1. There we go. Looks like 41.8 roughly. That sounds fine for that. And this is meters squared. Boy, that got pretty jumbled up there. We still got to find the volume. Well, the volume is actually easy. The volume of a prism is just base times height. Now, we already know what the base is. The base area is 5.76. And the height of the prism, we already talked about that, is 3. So we got to do 5.76 times 3. That was easy. 17.3. We already did all the grunt work for that. 17.3 meters cubed. So like I said, that was a tough problem. And recap here. The big thing is this is a trapezoidal prism. This is the base. And this is the height. This is the height of the trapezoid, but this is the height of the prism. A lot of people get that mixed up. We had to go and we had to search for the area of the base. We had to search for the perimeter of the base. And once we got that, it was just plugging into the formula. Alright, number 2. Find the surface area and volume of this. Now this is a, let's got 1, 2, 3, 4, 5, 6. Ooh, it's a hexagon. Okay, let's figure it out. Surface area of a pyramid is B plus 1/2 LP. And it's going to be another thing. We're going to have to go on a journey to figure out what the area of the base is and what the perimeter and the slant height. Wow, this is a tough problem. Like I said, if you can do this, then you can do it all. Alright, let's go look at the base. It's a hexagon. Let's do it over here. Here's our hexagon base. Okay. And it's got sides length of 4. To find the area of a hexagon, I need to use 1/2 apothem times perimeter. So that's going back to 11.3 for that one. Now the perimeter is easy. It's 4, 4, 4, 4, 4, and 4. So 4 times 6 is 24. The apothem is a little bit trickier. We're going to draw it in here. There it is. There's my apothem. And that would be 2. 2 and 2 make 4. And this ends up being a 30-degree angle right here. This is a 30, 60, 90. Look into what a hexagon is all about. Hexagons are going to have 60-degree central angles, which makes this 30 degrees. So this is a 30, 60, 90. So the short leg is 2. That means the apothem is 2√3. You got to go back to chapter 9 for that. Remember that? 2√3. Alright. Now this half and that 2 cancel off, so 24√3, which is approximately 24√3, 41.6. That's the area of that hexagon. That's what we plug in for that. This was the same P, so we can plug in 24 for that. It's the perimeter of the hexagon. The last thing we gotta do is find out that slant height, and this gets a little tricky. That would be like going down the side of the hexagon. So let's draw that triangle out here. That triangle that I just drew has 7 as the height. That's an apothem, which we found to be 2√3. That says 2√3. And now we can use Pythagorean theorem with that. So do 2 root 3 squared plus 7 squared, and do the square root of that. 7.8. Okay, so here's the deal. The height is 7, and the slant height going down the side is 7.8. Difference. Height, slant height. Slant height is what you use for surface area. Alright, so now it's all just plugging into my calculator. 41.6 plus 0.5 times 7.8 times 24. 135.2. Approximately 135.2. Now we already did all the grunt work, and this is surface area, so this is feet squared. Volume is going to actually be pretty straightforward. The volume of a pyramid is 1/3 base times height. Now we already figured out all the hard stuff. The base was at 41.6 that we figured out. The height is given as 7. And so we can just plug that all into our calculator and figure this out. So 1/3 times 41.6 times 7. About 97.1. 97.1 feet cubed, of course. So we got surface area and volume. This problem got difficult because it was a hexagon base, and that's just hard. You got to remember your 30, 60, 90 with the root 3 for that. You remember that? Yeah, that's what I thought. Base, slant height, perimeter of base. Volume, base times height, plug it in. Number 3 is a composite shape. So if we were to paint this, talking about surface area now, like say we were to paint this, would you paint the bottom of this cone? No, the bottom of the cone is not part of the surface area of this whole shape. So you don't want to do the entire surface area of this cone. You want to do the lateral area. So we're going to break this down. We're going to do the lateral area of a cone plus the lateral area of a cylinder plus the lateral area of another cone. 3 pieces as far as surface. We're going to paint this cone part, we're going to paint the cylinder part, we're going to paint the cone part. Lateral area, lateral area. We don't want surface area, we don't want to count these circles. Alright, so lateral area of a cone is pi RL. The lateral area of a cylinder is 2 pi RH, and the lateral area again of a cone is pi RL. Pretty sure we got most of this given to us. The radius is 8. The slant height, well, this is a 3, 4, 5 right triangle. 3 times 2, 4 times 2, 5 times 2, which makes the slant height have to be 10. The radius again is 8 of the cylinder, and the height is 10. And this cone is the same exact as the top cone, so we can use the same dimensions for that, which makes this 80 pi plus 160 pi plus 80 pi, which adds up to 320 pi, which we can go ahead and approximate. But 320 pi is a beautiful answer as a mathematician. It's a lot better than that looking. 1,000